Hello friends, welcome to Knowledge India once again. In this tutorial, we are going to talk about AWS Transit Gateway. This is a new service which got launched in reInvent 2018. So it has been just probably a week or two, right? Uh, and in this tutorial, what we'll do is we'll try to understand that why AWS Transit Gateway came into picture, what problems is it going to solve, and how should we go ahead and set it up, right? So I will be showing it to you with a detailed demo that how can you connect different VPCs together using Transit Gateway, and also the various other things in terms of populating its route table that that actually we find many times difficult. All right, so without any more wait, let us go ahead and get started. So I'm sure that you guys are already aware of the concept of VPC, VPC peering, etc. In case you are not sure about VPC peering, I request you to please watch our video on VPC peering because that's really important. You can see the link uh, here in the description or at the top of the video. Now, let's try and understand, quickly the background of Transit Gateway. Now, in many of the organizations, it happens that they would have multiple VPCs, within their setup. Now, this could be because of different reasons. Many of the times, it is that organizations divide their workload in different VPCs based on the environment, sometimes based on the department and things like that. Now these VPCs could be there in the same AWS account, or it could be there in different AWS accounts as well. And when the setup is like that, we go ahead and do VPC peering so that instances in one VPC can talk to instances in the other VPC, right? So this part you guys know. How to set up VPC connections, there's a detailed video separately on that on our channel already. Now, think of a scenario, think of a big enterprise where where there are a lot of different AWS accounts, and hence there are a lot of VPCs as well. For these VPCs to talk to each other, right, you have to do a lot of peering, right? As you can see in this diagram, what would happen is, let's say if you have got 1, 2, 3, 4, 5 VPCs to in an organization, you will have to do a lot of VPC peering. And managing this VPC peering, managing so many connections and everything becomes a pain point. Even if you go ahead and do it well, that's okay. But then there are certain limits as well, right? On the VPC peering, we'll talk about it. So typically, if you have, let's say, n number of VPCs and you want to try and create a full mesh, which means all VPCs should be able to talk to all other VPCs, you will need this many number of connections. So if we try and understand, let's say we have got 5 VPCs, we will end up having 5 into 4 by 2. So we'll end up having 10 VPC peering connections. Now this number drastically increases as your n increases. So let's say if you try to do the same for 10 VPCs, then what would happen? It would become 10 into 9 by 2, which is basically 45. So you need 45 connections. That's a hell lot of work to manage, and also you would be nearing the limit. What are the limits? Now, AWS poses certain limits on the, in terms of VPC peering. So on a particular VPC, you can have maximum 125 VPC peering connections, right? So think of a scenario that in your big organization, you have got different accounts for different departments and then various VPCs, and you have got a central account where you have all your tooling installed, right? Enterprise level tooling you have installed in a central account. Okay, now you do not want to go ahead and you do not want to go ahead and install this tooling separately in all the different accounts. So what you do, you basically create a VPC peering between the department account and the central tooling account. Now, in this way, the central tooling account will get so many connections from all the department accounts, right? And it there might be a chance that the central VPC or central account would hit the limit of 125. So that's a problem, right? And also you have a limit that how many routes you can put in your VPC's route table. So there are limits. You can put only 100 there. So see, if you have a small organization, probably you might not face these problems. But if you are working in a bigger organization, these problems do occur, and that is where customers gave that feedback to AWS, and AWS thought of making Transit Gateway as a service, right? So even before Transit Gateway, right, before Transit Gateway got launched, the bigger organizations were doing something with Transit VPC. So this model is slightly different. What they were doing was um, they used to maintain a central VPC. As you can see, this VPC in the center, and uh, and they were creating you know uh, like VPN connections from other VPCs. Like as you can see, this is the central transit VPC, and there are VPN connections from all these places. But then again, this means that you have to manage a lot of stuff in this particular VPC. Uh, all these instances which are there in this central transit VPC, which are responsible for routing the traffic to to other VPC or forwarding the traffic to other VPC. You need to be responsible for that. If an instance is going down, you need to have necessary mechanism that it is highly available and things like that. So yes, it was working, and many of the organizations might continue to use transit VPC as they have the setup already in place. But then uh, some amount of administration is required from the organization end or from the customer end to manage this. All of these things go away with Transit Gateway, which we'll explain you just in 2 minutes. One more problem which Transit Gateway solves. So before Transit Gateway, what used to happen was if you were, let's say, if you were connecting uh, your um, your VPCs to your on-prem environment, you are creating VPN connections. So think of an example that you have got um, three different VPCs. You've got a VPC for HR department, you've got a VPC for payroll, and you've got a VPC for let's say something else. I'm not going to, let's say sales and marketing department, right? So you've got three different VPCs. Now, if you want to connect these VPCs to your on-prem data center, what you are doing, we were creating three different VPN connections, right? Now, what would happen? In these three VPN connections, as you can see, the customer end would be the same. There would be one customer gateway which we would create, and that customer gateway represents the on-prem end of this tunnel, right? But on the VPC side, we will have three different virtual private gateway, in one in each VPC, right? And that's how we'll create this VPN connection. So for the bigger organizations where you have got a lot of VPCs and this way they have to create VPN connections, it becomes very difficult for them to manage it. Transit Gateway solves this problem as well, right? So what it would do is, if you are using Transit Gateway, it becomes a lot simpler. Doesn't matter how many VPCs you want to connect to each other, or you want to create a connectivity to your on-prem environment via VPN, you don't have to do it n number of times, right? Your Transit Gateway, as you can see in the center, it acts in that hub and spoke model. So uh, you can see that your transit gateway is there at the center. All from all the VPCs, there are connections which you can see, or you can think of it as we'll talk further. These are attachments. So these VPCs are all attached to this transit gateway. In the same way, a VPN connection coming from the on-prem would also be attached to the transit gateway. And what we will do that in this transit gateway, we'll be able to go ahead and manage, we'll be able to go ahead and define rules that from where to where traffic can flow, from where to where it should not flow, and things like that. I'm going to explain it to you with demo in a while. How do you set that up, right? So I hope you are following it till this point. Now let us go ahead and just cover 2-3 concepts before we get into the actual demo. Right? So I hope you are able to understand that how in case of you know, this type of peering, if we take this example, uh, you know, we had 5 VPCs, and if all 5 VPCs had to talk to each other, we discussed that you will have to create 10 connections, right? 5 into 4 by 2, that would be 10 connections. But with transit gateway, what you'll have to do is there will be one transit gateway in the center, and only as many VPCs are there, that many attachments you'll have to do. So if there are 5 attachments. Let's say if there are 10, only 10 attachments. Whereas in this case, it would have been a lot more. And in the same way, if you talk about this one, after uh, after your transit gateway, what would happen? That instead of having 3 VPN connections, you will be having just 1 VPN connection. So, oh, you know, all the traffic from your on-prem can come here, and then based on the rules which we are going to define in the transit gateway, it can go to VPC, ABC, anything, right? Okay, let's move forward. Let's understand 2-3 aspects of or concepts of transit gateway, and then we'll get started with the demo. So first thing is attachment. As I told you, attachment is basically a connectivity or a connection which you are creating between a VPC and a transit gateway, or it could be from a VPN to a transit gateway, as I showed you here, right? So you can also understand one thing, guys. When you create a VPN connection, there are two ends to it, right? The customer end or the on-prem end, let's say, the on-prem end is represented by customer gateway, and the AWS end or the AWS VPC end is represented by VGW, virtual private gateway. Okay. Now, if you are going to use transit gateway, the AWS end would be transit gateway instead of virtual private gateway. So instead of VGW, now it will be TGW, right? So first thing is attachment. So attachment can be a connection between transit gateway and a VPC, or a connection between transit gateway and a VPN connection. Okay. Uh, there is one more important thing, that you need to attach one subnet per availability zone in your VPC. I will explain it to you in more detail when we go to the demo, but it is important to understand that uh, if within your VPC you are using multiple availability zones, normally what we do is we'll have 2 availability zones, right? Of course, following the principles of high availability, we'll have 2 availability zones. So when we create attachment, at that time we need to choose one subnet per availability zone in your VPC. Please remember that. I will show it to you in the demo as well. Okay. Next thing is association. Now this one is very important. The association basically tells you that which route table within TGW would be used for which particular VPC, right? So let me show you here. As we go forward, we'll see that within a TGW there would be multiple route tables. Now the technical name for that is TGW route table, right? So there can be multiple. When you create a TGW, one one route table will be there by default. but then you can create further route tables there as you want. Now, association basically tells you that association tells you that which route table would be used for which VPC, right? So it's like the guiding thing. So for example, I can say that, let's say, route table 1 would be used would be used for VPC A, or route table 1 would be used for VPC B as well. What is important here to understand? uh, One route table can be used for multiple VPCs, right? But or basically for multiple attachments, right? You can use it, but understand that one attachment will have only one route table as the default thing. Okay, you cannot say that uh, uh, that a particular attachment will use route table 1 and route table 2 both. That way it won't happen, right? So that is something to understand. I will show this more in the demo, and it will become clear to you. And the next two concepts are propagation and routes. Of course, we are doing all of this to reach to this thing, to routes, right? Because as you know, in our route table, the routes which are there, those are the guiding principle. Routes tell us that what should be the next hop, where should the traffic go next, right? So this is what we want to reach. But in order to have these routes populated, we use something called propagation, because propagation can help you to automatically propagate the values in the form of routes, right? So I will show you that how can you put something in propagation and how does it affect and put things into the routes. Okay, so before we just go to the demo, just last things, what is the scope of transit gateway? It is regional. It's a regional entity. You create it in a particular region, and understand within the TGW, when you create attachments are zonal. That's why we were saying that you need to create one attachment per availability zone, right? Suppose if your VPC is using two availability zones, then you need to basically choose one subnet per availability zone, right? So we will show this more in the demo. Uh, Understand that TGW is regional, but it can operate across accounts. So it is possible that you can peer VPCs across two different accounts if they are there in the same region. So for example, the VPC A might belong to account 1, VPC B might belong to account 2, but it's possible to peer it via TGW. Okay, you can actually accept the attachment from VPCs in other account as well. That is possible, but across region it is not supported currently. We already discussed that you can connect not only to VPC but to VPN connection as well. And when you are using a VPN connection with TGW, then the AWS end would be TGW and not the virtual private gateway, which in short we call it as VGW. Okay, so these parts are clear. There are two things which are further coming up, which is not available as of now. That is inter-region connection. So later on, Transit Gateway would support that as well. And also support for direct connect. So currently you can use VPN connections with TGW, but not the direct connect connection. So that also would be coming in future. All right. So now let us get started with the demo. Uh, what we'll try to do here is we will have different VPCs, multiple VPCs, and then we'll use Transit Gateway to basically establish peering between these VPCs, right? We will also try to address few scenarios. As you can see on the right hand side, we will see that first one is very simple scenario that uh, all VPCs should be able to talk to each other, right? So we will do that. The second one would be would be more restricted. So basically, we will learn that how can we go ahead and control that, let's say VPC1 can send traffic to VPC3, right? But VPC2 would not be able to send traffic to VPC3, right? We will check that. Of course, VPC1 and 2 would be able to send traffic to each other, so that would be there. So we will go ahead and try to see that, right? Uh, so let us go ahead and get started. Guys, while we will we will do all the setup, one thing which is very important for you to understand and remember is that traffic flows in both the directions, right? So let's say uh, if traffic has to go from VPC1 to VPC3, the complete flow would be that a packet would go from VPC1 to transit gateway. It will then go to VPC3, fine, everything okay, and the response packet will come back and it will go to VPC1. So that way the complete traffic flow happens, right? So you will have to think of both to and fro, right? Just giving you this thing so that we are clear while we are doing things. I'll explain you as well, and we will also try to talk about few more things after we have done the demo. Okay, so let me go back to the console. As you can see, we are here in the management console. So first of all, let me show you what's the setup. So we have got three VPCs in place. As you can see, VPC 1, 2, 3. I've just kept very simple 10.1, 10.2, 10.3 so as to remember the VPC 1, 2, 3. So those are the CIDR blocks for all three of them. How does the subnet look like? So if you see, um, this is how it is. We have got one public and one private subnet in every VPC, right? Uh, though there is one additional, I have created one more subnet in one of the VPCs in VPC1, and there's a reason for that. I'll just explain it to you in a while. Let me show you. So if you can see, all the other subnets I have kept in availability zone 1B. Only this particular subnet I have kept in 1C. This is basically to show you that how does it differ when you have multiple availability zones within your VPC. In order to show that I have done this thing, right? But as far as the concept is there, I would be able to show you the complete demo using one availability zone as well. But this is to show you that if you have multiple availability zones, then where should you go ahead and choose the subnet while you are setting up your transit gateway. Okay. All right, so till here it's all simple. One public, one private. If you actually go ahead and try to look at the route table, let's say if you look at the private ones, what have we done? Nothing, just the default route table entry is there, nothing else. If you look at the public ones, well, for some reason it's not loading here. And I am experiencing this from yesterday. I don't think this is an internet problem because other things are all working well. Uh, this is where the whole microservices thing comes into picture. Maybe just this particular service is not working fine, and it doesn't bring down the whole screen or the whole application. So anyway, I just opened route tables here. So you can see that in the public route table, we have got a default local entry. All of you understand that. We have got an entry for IGW because it's public. We have also done an entry for the transit gateway. So let's understand this entry. What have we done? This particular route says if the traffic is destined to go to 10.0.0.0/8, send it to transit gateway. Now, it is important to understand here, if you look at these three VPCs, you can see their CIDR blocks or the CIDR range. What are we saying? That, see, I'm defining a range of IP address or a CIDR block in the route table such that it actually encompasses all of these CIDR blocks, right? So that's why I'm actually picking up a bigger one and I am putting it in the route table here. So think of a scenario. Let's say an instance which is there in this particular VPC is trying to reach out to another instance which is there in 10.2.0.0 in this particular VPC. What would happen if we go and look at this route table? The route table would be right. Yeah, this one. So if we'll try to see, the first route would not be met, right? Because the IP address which it is trying to reach, it is there in the 10.2 range, right? So this one would not be met. Then the second nearest one would be, or the second closest one would be this particular CIDR block. And hence that particular packet would be sent to transit gateway. Well, I will show you that complete flow just in a while. So anyway, we have our subnets in place, right? Great. Now, what are we doing next? Next is just creating the transit gateway itself. Now, I have done few things, guys. Few things I just created because on every step of transit gateway, when you create, it goes into that processing thing and hence takes time. So what I did, I just created a transit gateway. It is just one step process. You have to go press on create transit gateway, give it a name, description as you want, an ASN if you have a specific ASN which while you are connecting it to on-prem, that time it becomes more important. DNS support, good thing is now you have DNS resolution supported. So instances in one VPC can reach out to instances in the other VPC using its DNS name as well, not only the IP address. So that's a good thing which got released very recently. ECMP support, what is ECMP support? ECMP is a new feature which Transit Gateway supports. It is equal cost multipath. So basically, with every VPN connection, there is an upper limit, or there's a limit that how much bandwidth it can support. I think it is 1.25 Gbps. But the point is, with the Transit Gateway, what you can do is you can have multiple VPN connections going to the let's say going to the same on-prem going to the same on-prem data center. Now, instead of one VPN connection, if you create multiple VPN connections, what happens is the traffic which is going to your data center can actually flow across these multiple VPN connections. And as it says, equal cost multipath, because the target is same, the traffic goes via multiple VPN connections or gets distributed via multiple VPN connections, and hence you can achieve a lot more traffic. So if on one VPN connection you can achieve 1.25, think that if you have put 4, automatically it becomes 5 Gbps. You can achieve speeds up to 5 Gbps. That's a great thing. Default route table association, route table propagation. So as I told you, when you create a TGW, a default route table gets created, right? So it is for that. If you want to also accept connections to your transit gateway from VPCs which are there in other accounts, then you can enable this. Now, I'm not covering this in this particular video because I want to talk about resource access manager, uh, altogether in a different video. So I will do that separately. And then you just press create transit gateway and it gets created. So I have kept it created. So here we have our transit gateway in place. Okay. In the VPC dashboard on the left hand side, you have transit gateway, gateway attachments, and gateway route tables. So next thing is gateway attachments. So there are 3 attachments which will create here. So as you can see, I will not be able to show you the VPN thing for now, right? But I will show you at least how things work in terms of different VPCs. The VPN also would be nearly similar, and I will show you at least the steps in this particular video. Okay, so I have created the 3 attachments. These are there for 3 different VPCs, as you can see. So we have got 3 VPCs. For those, we have created 3 attachments. How do you create attachment? Very simple. Just go ahead and say create gateway attachment. You have to then choose your TGW, right? So whatever TGW you have, you can choose it, and you will say this attachment attaches what, whether it will attach a VPC to the transit gateway or it will attach a VPN connection to the transit gateway. So let's say if you are saying VPC, you can choose that, give it some name, as I have given one attach or two attach, whatever you like, you give it some name. DNS support you can enable. If you want IPv6 also you can enable, and then you can go ahead and select the VPC. I've already selected, so I'm not doing this again. In case you are doing VPN, you can go ahead and choose VPN, and after that, if there is a customer gateway, you can choose that customer gateway, choose the routing option, whether you want to do BGP or static, same as you create a new VPN connection, same things, right? The only thing is, in this case, instead of virtual private gateway, you are using transit gateway. That's all. Okay. So in that way, I have gone ahead and created three uh, attachments, which are there for three different VPCs. So till this point, it's all very, very simple. Just one step thing. You can go ahead and very quickly do all of this. The actual stuff or the thing to understand starts after this, right? So here is your gateway, transit gateway route table. So as we discussed, that one gets created by default. Let me just name it as well, default. So God knows why name is coming two times. So I am also seeing this a bit of UI glitch at many of the dashboards. The name is coming two times. This is happening for the past few days. It's not there in with all the entities, but surely there with some of them. Anyway, so this is the default transit gateway route table. And now we will go ahead and try to understand how does it work. So as I told you, there are three things. There are three concepts which we talked about, right? I told you that we'll have to understand attachment, association, propagation, and route. So attachment is very simple. We have discussed it, right? Uh, Now this part I missed to show you guys. I'm sorry. Let me go ahead and just show it to you quickly. So in the attachment, when you say create transit gateway attachment, and just I'm giving uh, some name, and I'm going to choose a VPC. Now I'm going to choose a VPC which has got two different availability zones. This is the reason why I had created another subnet in another availability zone as well. So you will see that when I choose that particular VPC, I am getting both I'm seeing both the availability zones where it has got subnets. So I need to go ahead and choose in 1B, I need to choose any one subnet. And in the same way, 1C, I need to go ahead and choose any one subnet. So it's up to me that, which one I go ahead and choose. It's totally up to me, right? And well, though it doesn't matter much in terms of whether you choose a public subnet or a private subnet, it doesn't matter in that way. But what's recommended? That's important to understand. What is recommended? If you are setting up your VPC and transit gateway newly, and if it is possible for you to have a completely separate subnet per availability zone to connect to your transit gateway, that is best. Okay, why is it best? Because there are few advanced use cases which you will be able to achieve using that. Okay, so what I'm saying is, let's say when you are setting up your VPC, normally in every availability zone, we will have one public and one private subnet, right? So in the same way, what you should do is you should go ahead and create one more subnet in that availability zone, which is just for the attachment purpose to transit gateway. It can be a very small subnet. You need not keep it big, right? Why is it important, guys? What happens is when you choose the subnet here, whichever subnet you will choose, there will be an ENI which gets created in that subnet. Okay, and that ENI basically connects to the transit gateway. That's how it works, right? So while you are doing this, uh, check your subnet before you create the transit gateway. And after creating the transit gateway, when you create these attachments and you choose the respective subnet here, and you say create attachment, you will see that the number of available IPs from your subnet would get reduced by 1. Okay, so that's very important. You while you do that, you can check it as well. So please keep that in mind. So that's what I wanted to show you here. Now I'll press cancel. I'm not gonna create that. We already have all the 3 attachments created. Okay, so coming back to our this thing. So um, uh, we have got association, propagation, and route. So attachment is clear. Next is association. Let's look at the definition. Association tells that which route table would be used when the traffic is coming from a particular VPC, right? Or from VPN. So in this case, if you see, in the association, we have all the 3 VPCs. These are VPC IDs, if you see. EF, E765, right? So these are the VPC IDs, the 3 VPC IDs. So currently I have associated all the 3 attachments. One attachment is per VPC. So all the 3 attachments I have associated with this route table itself. So which means this route table will act as the guiding guide, or will act as the guide when the traffic is coming from these VPCs. Great, association done. So in propagation and routes, how is it helpful and what does it do? Understand that, let me tell you routes first. So routes is there basically it tells that what all routes are available. So in this route table, we have got these 3 routes. So what does it say? If the traffic is destined to go to, let's say, 10.2.0.0/16, send it to this particular VPC via attachment 1DC. If you see what is attachment 1DC, let's see. Attachment 1DC goes to second VPC, right? As you can see. So basically, if traffic is destined to go to this range, send it to second VPC. If the traffic is destined to go to this range, send it to third VPC, and things like that. So these are the routes. And how did we get these routes here? I did not come and manually entered these routes here. These got propagated, and that is where propagations come into picture. Okay, so as you can see uh, on this particular tab, I don't know today okay, here it is. So on this particular tab, you have propagation. So uh, in propagations, what you do, how do you create a propagation? In propagation, you basically go ahead and choose any attachment, right? So when you choose the attachment, you remember attachment is either to a VPC or to a VPN, right? So whatever is the CIDR block of that VPC or VPN will be populated into routes based on what you write in the, or what you add in the propagations tab. The respective routes will get added into the routes tab. Okay, so as you can see, for all these 3 different propagations, there are 3 different VPCs. There, for those 3 VPCs, the respective CIDR blocks got added as routes here. So this is great. Now, why is it useful? It's useful because, let's say, for a particular VPC, let's say for VPC 1, in future you go ahead and you actually increased the CIDR blocks. As you know, now it is possible to actually add additional CIDR blocks onto a VPC, right? So maybe, let's say in the VPC 1, currently you have 10.1.0.0/16. Later on, you also create 10.9.0.0/16 as well additionally. So if you do that, you don't have to come and manually add a route here, because you have propagations put here. It is the work of this propagation concept to automatically propagate that CIDR block here in the routes tab. Okay, so you don't have to come and do manually. That's the advantage of using propagations. Okay, the last thing is, in case of routes, whatever you have put in the propagations, from that it comes. So as you can see here, you have all these values as propagated, and you cannot select and delete these, understand, right? If you don't want these to come here, then you'll have to remove the propagation itself. Okay, a particular propagation can be deleted. You can select and delete it. Now, In addition to what comes via propagation, if you want, you can also create additional routes on your own as well. So for example, you can go ahead and say create route, and you can give a particular CIDR block, and you can say to which attachment the traffic should go. You can go ahead and do that manually as well if you need to, right? Sometimes you want to create something custom, you can do that. An important one there is black hole. Sometimes we want that traffic should never go to a particular IP address or a particular range of IP address, right? So let's say I have got something very critical in, let's say, 10 dot, and I can create a black hole entry as well, something like this. If I do this, so give it a minute. Yeah. So as you can see, this route type is static. So static is something which we create. Propagated is which comes automatically. And always understand, if there is a conflict for a particular path, always the static ones take the priority or will take the precedence above the propagated one. Okay. So what I'm saying is, if traffic is destined to go to this particular IP address range, then just drop that. Do not send it anywhere. So I've created a black hole type of route. Let me try to show you. Yeah. So as you can see, I've created this black hole thing. So traffic would not go, it would be just dropped. So I hope you understood all of this. So I'll just go ahead and delete this route now. Okay, so first, now we will show you. So as you can see, every time when you do some operation here, it takes few seconds for it to reflect, right? So now let me first show you the first scenario, that how all the instances can talk to each other, and then we will do the next one where we will create custom or newly created transit gateway route tables. So we'll do that. So be with me. This is a long video, but there are a lot of concepts to grasp. So if you are missing something, just please pause it and see it again. Okay. So uh, let us see here. So we have got different EC2 instances, and I have named it as well accordingly, guys. Same. So we have pub1 in VPC1, 2 in VPC2, and so on. The pub11 is there in again in our VPC1, but it is there in the another subnet, right? So basically, if you see, it is there in the subnet 2752, which is this one, 2752. So the reason why I created the reason why I created that particular EC2 instances, I will show you that because we do not have attachment for this particular availability zone, which is 1C. So peering from this instance would not work. Okay, I'll show you that as well. All right, so I hope we are good till this point. Let us go ahead and connect to the instances. So I'll connect to all these three instances using their public IP, and then further I will show you how do we check the connectivity. So just give me one moment, I'll establish all the connectivity. All right, so I have created SSH connections to all the three EC2 instances here, pub1, pub2, and pub3. And I will now go ahead and show you the peering test. Before we do that, please remember that in the uh, in the route table of your subnets, right? Uh, you will have to put a route to the transit gateway, which I showed you already. I hope you remember that, something like this. So all the traffic which you want to send to the other VPC, you will have to accordingly decide a CIDR range, and you need to put a route onto your route table, VPC route table, that it should go to transit gateway, right? It is very easy. You can always just say add route and just specify the CIDR block, and then choose the transit gateway, and you'll be able to select the transit gateway which is there. Okay, so just wanted to show you that. Now let's go to all the three different uh, connection. So as you can see, I've connected to all three of them. Let's try for the pub1. This is the public IP with which I connected. This is the private IP of that 144. From here, we will try to do a telnet to this particular thing. So let me copy this. And so as you can see, I'm there on 10.10.44, 144. I've already installed telnet on this particular machine to this particular thing on port 22, and see it goes through. So from first VPC to the second VPC, VPC1 to VPC2 connectivity is happening. Great. Uh, let us try to check to the third one. So this is the private IP. Okay. Even this is going through, right? So we can go ahead and just quickly to verify, we will show you for the other one as well. So this is the instance in VPC1. I will go to, let's say this one, which is VPC2, 10.2, and I'll do a telnet. And you can see this is also going. So very well, I think this is all working good. So without wasting any more time, right, we will now go to the next thing, which is even more, a bit more complex to do and understand, right? So next thing, what we are gonna do is this particular scenario. VPC 1 and 2 would be able to send traffic to each other, great. VPC 1 would be able to send traffic to VPC 3, but then VPC 2 cannot send traffic to VPC 3. Okay, all right, great. So as I told you, you can go ahead and use different route table for every attachment, right? So let us go ahead and do that now. So now we'll go to transit gateway, and what we will do is uh, we will go ahead and create different route tables. We'll go ahead and say create this, and just for easy understanding, I will say TGW RT1. This I'm creating for first one. So we'll just say transit gateway. So understand table for table is the scope of a particular table is limited to that particular transit gateway. And further, I will show you how will we do association. So you can see I created it. It is yet to appear. Oh, just one sec. It is getting created, and I had filtered it. All right, so we'll create the other two as well. TGW RT2. Good. And one more. TGW RT3. Okay, great. Now this is all created. Now what we'll do is, as I told you, you can use only one route table for one particular attachment. Currently, for our all the three attachments, default route table was getting used. But now what I want to do for the attachment one, I want to use route table one. So I'll go here and I'll try to create an association between an attachment and this route table. So I will try to choose attachment one and I'll say create association. But this will not work. Reason being, already attachment 1 is associated to another route table. So first we'll have to remove that. So we'll go to the default one and we will just delete this. I'm going to delete all of these because anyway we want to. Okay, so as you can see, two are already gone and this would also go away. We will now go ahead and try to create the association for our route table 1, and this association is going to be to the attachment 1 which is there to VPC1. Okay, so and it is created successfully, as you can see. We will go ahead and do for other two as well very quickly. And I've kept the names simple so that it is very easy for you to relate. Uh, see, remember one thing, guys. Currently, yes, I am going to, the way I'm setting it up, I am creating different route tables for every attachment. It's up to you. You can go ahead and use one route table for two attachments as well. It is possible. So what you can do, for example, in this route table itself, I can go ahead and create one more association, and that will be there for attachment 3. I can do that, right? But in order to keep things very much segregated and very clear, I'm explaining it to you with with 3 different route tables, and that would be good also when you want to manage and segregate rules and everything. Okay, so I'll go ahead and create third, say create, right? Okay. So all these 3 things are done. As you can see in default, there is nothing now, and in the other, we have got necessary associations done. So now the first step is completed. With this, we know that when traffic is coming from a particular VPC via a particular attachment to the transit gateway, which route table would be used. Okay. Now, what do we want to do? Let's review this once again. VPC1 and VPC2 should be able to talk to each other, right? Very good. Okay. So what we'll do is we'll pick up this one. We'll go to propagations. And here we'll say that when the traffic, you see, this is there for attachment 1 basically, right? So traffic is coming from VPC1 and we want it to go to VPC2. So in the propagations, we will attach uh, the VPC2's attachment, which is attachment 2, we will attach that. So we'll say create propagation. Nothing, it's very simple. We have to just go ahead and say this one and say create propagation. So done. So what would this do in turn is that it would go ahead and create a route in the routes tab. So please understand it very clearly. So what is happening in the route table, which is there for attachment 1, in turn VPC1, there we are saying that, traffic can go where all? It can go to 10.2.0.0/16, which is basically the CIDR for the VPC2, right? So this is done. So traffic can now go there, right? But understand, when traffic has reached VPC2, it has to return also. And for returning, it would need a path back to VPC1. Now, when the traffic is returning from VPC2, right? Let's see here. When the traffic started from VPC1, now it has reached to VPC2. That is what I showed you now. Now from here, from VPC2, when traffic is returning to VPC1, it would also need a path. So from VPC2, when traffic is returning, which route table is getting used? The route table 2. So let us go to route table 2. So in route table 2, we already have the association, right? Because of that only I said that route table 2 is getting used, right? Route table 2 is attached to which attachment or VPC? To VPC2, right? So now, basically it's very simple. It would need a path back to VPC1. How would we give that? We will go and attach it in, we'll go and establish it in the propagation. So we'll go ahead and create a propagation for VPC1 or attachment 1 and we'll say submit. So with this, there will be a path created in the here. So what have we achieved now? Now we have achieved that from VPC1 traffic can start, it can go to VPC2 and it can come back. That's possible, right? We can go ahead and check this as well. Till this point, it is simple. I hope you understand. And now we can go ahead and see whether from instance in VPC1 we are able to reach out to instance in VPC2. But please understand one more thing before we go there. If you look at both the route tables, you have got you have got routes for the other things. So let's say in the route table 1, you have got a route for the VPC2. In the same way, in the route table 2, you have got a route for the VPC1. So this actually means if you, whatever I explained you from VPC1 to VPC2, if you just start seeing it otherwise as well, let's say the traffic originated in VPC2, went to the VPC1 and came back, that would also work, right? So let us go ahead and check. This is my instance in VPC1. So I'll try to do this, and it is going through. Uh, and this I'll try to do, and this is also working. Great. Just we can try to check if it is doing a telnet to instance on the third one, which is this, but it is not going through, right? So currently to the third VPC there is no connectivity. Fine. Let us now achieve the last part of this, which is that VPC1 can send traffic to VPC3. So basically 1 and 3 can talk, but 2 and 3 cannot talk, right? So what will we do here? Let's go to this, and here we will attach one more propagation now. We'll say, or we'll create one more propagation now, I'm sorry, which is there for third, and we'll say create. So basically we are saying from the VPC1 traffic can now go to VPC3. If you go and see the routes, you'll be able to understand that, right? Great. And now for the traffic to come back, what we need to do? We need to go to the route table for the VPC3 or the attachment 3. And here association is already there. We need to create a propagation. Where do we want to allow the traffic to go back? We want to allow it to go back to VPC1. So we'll create a propagation. We'll say, we'll choose the first attachment, which is for VPC1, and we'll say close. So now this is done, and you can see the routes here as well. So what have we done? We have actually achieved that VPC1 and VPC2 can talk to each other. VPC1 and VPC3 can talk to each other, but VPC2 and VPC3 will not be able to talk to each other. We will check that now in our this thing. So just some time back, it did not go through. Now we'll go ahead and run again, and you can see from the instance in VPC1, we are able to connect to an instance in VPC3. I'll try to do the same thing from instance in VPC2. So understand, from VPC2, it should not go through. As you can see, it is not able to reach out there. All right, the last one is from the instance in VPC3. What would happen? We'll be able to reach out to instance in VPC1, but not to VPC2. Let me show you that as well. Telnet 10.1.0.144.22 ups. So on this instance, we don't have Telnet installed. So you need this client. Just copy this. All right, so this is done. I'll do this, and you can see VPC3 is now able to connect to VPC1. Great. What if it tries to do to the it won't go through. So with this, I hope you understand that how can you go ahead and manage to a very, very granular level all the routes. Guys, the whole juice is there in this particular thing, in the transit gateway route table. This is really, really great stuff, and it's very important to understand how does the association, propagation, and routes work. Remember that I'll just summarize it once again. An attachment refers to or points to one VPC or a VPN connection. Every attachment or one attachment can be attached only to one route table via association, right? So it can be associated only to one route table. Yes, it is true that one route table can be associated to multiple attachments. That's possible, right? And you have understood for what purpose propagation and routes are there. When you go ahead and create a propagation, you are basically saying all the CIDRs which are there in this particular VPC, those should be propagated as routes here in this routes tab. you can also go ahead and create your own static or custom written routes here as well, which I showed you. I hope I hope you understood what is transit gateway, uh, guys. So this is what I was talking to you. Please remember this. Uh, and this was a really long demo, right? Took a lot of time to prepare. If you have seen it till here, I request you to please like this video, share it with your friends. I just thought of telling this time that it took a complete 6 hours of work to basically make this video, right? So please share it with your friends. If you like this, please go ahead and write it in the comment section. Uh, if you did not understand it, or if there are a few doubts, I suggest that first you try to do it on your own. Please go ahead and in your AWS account, create this full thing, test it on your own, and you will be perfectly clear. It is, the networking concepts in AWS are becoming more and more complex. Unless until you go ahead and do it on your own, you would not feel confident. So I request you to please go ahead and try it on your own. Become confident. There are more videos on our channel related to VPC and so many other stuff on related to AWS. I request you to go ahead and look at those videos. Uh, Tell your friends about this channel. Help us. Uh, we have more videos coming very soon. Just that there are so many announcements which have happened recently, and those announcements are actually changing a lot of concepts. So I'm just trying to streamline things, and I will bring more videos very soon. Till then, remain connected, subscribe to our blog, and you can follow us on our different social channels. Look at other videos, and I will see you very soon once again in next AWS video. Thank you guys for your time and support here. Bye bye.